Hello friends, today we are going to discuss the chapter electromagnetic wave in 12th physics. Chapter 8, in this we will study about electromagnetic waves, how are these waves produced, what are these waves and what are their characteristics. What are electromagnetic waves and how are these produced by electric charge and what are their properties. Electromagnetic waves do not need matter to transfer energy. These are made by vibrating electric charges and can travel through space by transferring energy between vibrating electric and magnetic fields. How do moving charges create magnetic fields? Any moving electric charge is surrounded by an electric field and a magnetic field. That is, it has both electric field due to charge and magnetic field due to its motion. Or we can say a changing magnetic field creates a changing electric field. One example of this is a transformer which transfer electric energy from one circuit to another circuit. This topic we have studied earlier in previous chapter, electromagnetic induction. In the main coil, changing electric current produces a changing magnetic field, which then creates a changing electric field in another coil, producing an electric current. The reverse of this is also true. Here we see electromagnetic wave. The electromagnetic wave is going in a particular direction, which is shown by the arrow. Both the electric field vectors and magnetic field vectors are associated with it. In the diagram, we have seen electric field by yellow color and magnetic field by blue color. As we can see, when electric charge vibrate, the electric field around it changes, creating a changing magnetic field. Or we can say the magnetic field and electric field creates each other again and again. An electromagnetic wave travel in all directions. This figure shows a wave traveling in one direction, carrying electric field vector and magnetic field vector associated with it, which are vibrating perpendicular to each other. Here we see electric field vector and magnetic field vector both are changing sinusoidally. The electric and magnetic field vibrate at right angle to the direction of the wave travels. So it is a transverse wave. That is, electromagnetic wave is a transverse wave. Transverse wave are those waves whose vibrations are perpendicular to the direction of wave motion. Here we see in the diagram, electric field and magnetic field vectors vibrate perpendicular to each other and also perpendicular to the direction of wave motion. So this was the electromagnetic wave. How are these produced? By accelerating charged particle. Now properties. All matters contain charged particles in the form of electrons or protons. that are always moving. Charged particles are not in rest. These are all moving in their orbits. Therefore, all objects can emit electromagnetic waves. The wavelength becomes shorter as the temperature of the material increases. This means greater the temperature, greater is the frequency of the wave emitted, and shorter is the wavelength. Electromagnetic waves carry radiant energy. What is the speed of electromagnetic wave? In vacuum, in free space, its speed is 3 lakh km per second. That is 3 into 10 power 8 meter per second. This is called as speed of light also. Light is a part of electromagnetic wave, and this is the limit of the nature. No particle have greater speed than the speed of light. In different media, speeds are different. In vacuum, air, water, glass, diamond. These are some transparent media through which speed of light is given. Here we see denser is the medium, smaller is the speed of light. So speed of light is maximum in vacuum, goes and decreases in gas, liquid and solids. The characteristics of wave have wavelength, frequency, speed. Wavelength of wave means distance from crest to crest or trough to trough, or we simply can see the distance between 2 points of the wave which are in same phase. That is called as wavelength. Frequency, number of wavelengths that pass a given point in 1 second. As frequency increases, the wavelength becomes smaller. One more topic is associated with characteristics. Can a wave be a particle? In 1887, Heinrich Hertz discovered that shining light on a metal caused electrons to be ejected. Whether or not electrons were ejected depends upon frequency, not the amplitude of the light. As per wave theory, energy of light depends upon amplitude, not on frequency. But Heinrich Hertz observed that ejection of electron depends upon frequency, which shows wave as a particle. Reverse is also true. In later years, Albert Einstein explained Hertz's discovery. Electromagnetic waves can behave as a particle called a photon, whose energy depends upon frequency of the wave. As we say, reverse is also true. Particle can be a wave. Yes or no? This was demonstrated by an experiment. Electrons fired at two slits actually form an interference pattern similar to pattern made by waves. Means electrons show the same pattern as shown by the waves. Electrons being particles showing the wave pattern means waves are associated with electrons also. The particle can have wave nature. This is the pattern of electrons fired at two slits, and same pattern is obtained by waves. This we will discuss in next chapters of wave optics. That's for today, showing the properties of electromagnetic waves, how are these produced, and how can changing electric field produce magnetic field, and changing magnetic field produce electric field.